S-Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, we all know that what is the use of the digital electronics in our day-to-day life. What is every machine that we are designing now, they are more into digital.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to the S-Chan Academy, and my name is Kanhaiya Jha, and today we will discuss more about the digital circuits, that how digital circuits are designed, how these circuits are generally used in the industry and all. So digital electronics fundamentals we will discuss today. So for the particularly digital circuits, we'll all know that how we make the circuit of AND gate, OR gate, NOT gate, then how we combine the circuits, and after combining the particular circuit, we make NAND gate, NOR gate, exclusive OR gate, and after that we have made a number of gates. After that we have made integrated circuits using this particular logic gates. So by using this, we form a register. Register is basically used for two particular functions. The first function is data storage, and the second function is the data accessing, or we say data movement. Shift registers provide a data movement function, and it is used for the output in the particular cycle. So basically what is a register is that register is a circuit. That circuit allows us to store the particular data, and after storing the particular data, how to process the data so that the data can be used from one particular form to the another particular form, from one particular place to another particular place. So we are using this. So if we look at the particular diagram of this, data are used in bit, 1 bit, 2 bit, 3 bit till n bit. So we can see here this is a serial in. Then the data are used in the register with a particular bit form, and then it is series out. So we say that we have three things in this particular shift registers. One is a preset control, one is a shift control, shift pulse, and then the clear control. So basically we have two things with us. The first thing is data in bits, and the second thing is a pulse. They both are a particular indication when the time duration taken is very small. So as we have discussed in the previous video, that in the analog we are using the initial time to the final time, but in digital we are breaking the time period, and when we are breaking the time period, we are calculating the time period into small pulses and the data in the small bits. So when we are calculating the time period in the small pulses and data in the small bits, then they are in the form of the particular register, and that these circuits are very much capable of storing the data, and along with the storing of data, they can be used while the data can be flow from the one particular form to the another particular place. So we can see here that a logic circuit diagram is shown in this, which is showing a SR flip flop, okay, and they are connected to the D flip flops. So we can see here serial in and the shift register. Here we are using this particular gate. Then they are the particular register form PQRS, SQ and RQ. This is SQ, RQ, and this is the clock. SQ and RQ, and there is a clock. So here we have an input port which is serial in, and then the output which is serial out. We have a shift here where we can see here clearly the signal is sent, and then the signal will pass through the register, and then we will get an output. Especially students, if you have any issues with this particular gate, this is usually we are getting a NOR gate. We have some presentation here that this is used always for the not abbreviation, that when we are using the not gate, we are using it. When we are using the NAND, we are using this. So here it is A and it is Y, and here it is A, it is B and it is Y, and here we are using this particular NAND abbreviation. So we can see in our circuits that how they are generally used. So this is the particularly not abbreviation that we are using, and then we are forming a particular shift register. So this can be used for the n bit. So this name is called as a n bit register. So this is connected with the flip flops, and then it works with the clock shift. Clock shift in the sense that it can be used for the small time pulses. The time pulses may be taken as very small, even seconds. In some of the cases, it can be taken as a microseconds also. That the time period is taken in a small bit, so that if there is any distortion or there is any damage to the particular input signal, they can be calculated very easily. If there is any damage to the input signal, they can be calculated very easily. This is the purpose of this particular shift registers. Then as we can see, there is a symbol given. Then we have shift registers as a flip flops. We have serial in, serial out. So we can here see that this is a serial in, SI, and SO is basically used for the serial out. The output of the flip flop is connected to the input of the D input of the flip flop at its right, and each clock shift contains a register. Clock shift is basically for the time, it contains a particular register value that is called as a data value. For that particular time of pulse, that data will be stored, and then that particular data will flow from one particular port to the another port. So here we can see from a particular serial input, we are getting an output with a particular logic with the n bit data and the clock connected to it. So for the proper flow of the digital signals, we make the particular shift registers, and the purpose is that the entire data is break into the bits, the small form, and the entire time is break into the small time pulses. So when we break this into the small time pulses, then what happens? This is basically that we are forming a particular register, and the register is basically connected with a particular time pulse. The time pulse may be any time pulse. It may be low, it will be seconds and the microseconds, and then the data can flow from one particular point to another particular point. Then we have serial to parallel conversion. We can see that this is an n bit register, which is we have a parallel output, there is serial in, and then it is a shift pulse and then clear control. So we have a parallel control here where we can make the data serial here, then there is a clear and the clock. Again, with the different varieties of the input and the different varieties of the output, we are making it. Again, we are letting the data to break into the small bits and the time to be break into small time pulses. So this is basically serial to parallel conversion. The diagram is basically shown to you. And then after receiving a particular signal, from here they receive the particular signal. From here the data and the time pulse are decided as far as the requirement is concerned and the machine is concerned, and then we get a particular output. So here in this particular shift register, we are making the particular signal to flow in such a way that whatever the circuit that we make, that the signal will flow on that, and in spite of analyzing the entire signal together or entire data together, we are breaking the data into n bits. Bits is basically a smaller version of the particular data when you break it, and the time pulse is that when the entire time given is break into the smaller time pulses. When the entire time taken is break into the smaller time pulses, that is called as a data pulse. So where the data will flow. So first we have discussed that JK flip flops, then we have discussing the serial to series to parallel. That in first case we have discussed that the registers were connected in series, then a series particular register can be converted into the parallel register. So conversion of the series to parallel registers here. Then we have series to parallel conversion. We can see that series is serial in given to you, then we are using a clock. Again the pulse will be decided, that the smaller pulse will be taken and then we take the particular output. So we can say that we are giving the input here, we are using the clock, and then from that particular clock, using the small time pulse, we are calculating the particular output. So we will use the serial in and the parallel shift registers of the particular length. It depends upon that what is the the value of data. According to the value of data, it break them into bits, and according to the total time, will break that time into the smaller time pulses. So this is the second conversion that we have seen. Here it is a parallel to serial conversion. This is a logic circuit for the parallel in, series out shift register. So from here this is the load shift, there is a serial in 0 and then it is 1D and this is 2D and this is like the multiple nth number, which is much like. So it is 0 1 0 1 0 1, and then using in the output we are getting the output with a particular clock and the time pulses, and here we can see that this is the serial out. So we can see that here, that how the input is given, how the input is varying with a particular clock, what is the changes which are occurring in the input. We can always use the input and the output in terms of the 0 and 1 in binary notation, as we have studied in the lower classes how to make the truth table of this. So we can see here that how the input is generally given, and from this particular input we are making the small time pulses and we are getting the output. So in a very general language, what we are doing is we are making a circuit. That circuit can work on the small time pulses. These are the basic circuits that we have done in the lower classes, and then here we can see that this is the AND operation that we are using here, and 0 1 1 0 and 0 1, and then we are calculating the particular output. So this is parallel to series conversion here. Then we have parallel in, parallel out. As we know that parallel in, parallel out is basically that when the data is allowed from a temporary storage and the time delay devices. This is basically the study of registers for the time delay devices. So parallel in, parallel out, we will see that how the input pins PA to PD, we have shown it, PA to PD, okay, and then the output for QA to QD is generally connected. So basically in this particular parallel in, parallel out, we have an input mode, we have output mode. The data will flow from the input mode to the output mode, and then the conversion will take place. So we have counters. Counters are basically used for the clock and the count. Whatever the time period that we decide, the counters are basically used to evaluate that particular time periods, that either the time period is small or time period is less. Here we can see that this is a clock, this is a counter, and this particularly count. So this is a circuit that produces a numeric count each time the input clock pulse make an active transition. Basically when we were doing concept for the modulation, then we have done a lot with the time periods. Whenever we make any particular series, in that case also we have done a lot related to the time periods. So here also we are doing a particular lot of things related to the time periods, that how the time period variation can be calculated, how we are using the counters, how we are using the clock and the counters and everything. So this is how the counters are generally used. Then we have applications that includes system clock, that include timers, delay. We can see the digital watch, which is a clock, alarm clock, timers, then counting events, memory addressing, frequency division, sequence control, cycle control, protocols. Basically, after the what we have used for the digital clocks, what we have used with the particular sequence control, the most important thing that we are using it is a frequency control, that it will not only show the time, or it will not only show the time period after which it is used. Frequency control, we set a particular frequency, and after that particular frequency the repetition happens. So we can see here counter types. We have modulus, ripple is a binary, then synchronous, then clocked. Here we can see 001, 101, and here it moves up, down. Linear feedback shift registers counter. They are called as LFSR, linear feedback shift registers. These are the counters, linear counters, as we have discussed. This is a small explanation in terms of the flow diagram. It is given here that how the particular counters can be used. A synchronous ripple counter with the input and the output Q1, Q2, Q3 and Q0. So we'll take 2 as an input and 2 as an output, and we are calculating it for the input and then for the particular output ways. So ripple counting timing, we have a ripple factor with this. We calculate the shift registers, all the ripple values and all. So here what we have discussed about the shift registers, we have discussed about the particular circuit, we have discussed about the particular time delay, how the circuit are made, how the particular time frequency is set. So now we'll take a small break and we'll discuss later.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Hello students, welcome back. So we are doing about the shift registers. We are doing about the synchronous mode, that how they are used in the synchronous mode, how the data can flow from the one particular form to the another particular form. Okay, how the time frequency is generally set. Time frequency is generally set. That how we are taking the initial time, how we are taking the final time, and then the variation in the time is calculated. So we have a 4-bit counter here. We can see it. This is a 4-bit counter. We can see 4-bit counter here. Then this is connected to a particular circuit. This is a synchronous counter, and then we have Q0, Q1, Q2, Q3. So we'll start the counting from 0, 1, 2, 3. It is a 4-bit. So 4-bit we are starting the particular counting from Q0, Q1, Q2, Q3 and Q4. Then we have basically the shift register. So what we have learned, that how the shift registers are generally made, how we calculate the particular time propagation, how we fix the particular time frequency, and then we calculate the variation in terms of the particular time frequency and all that. So now we'll discuss something about the microprocessor, that how the microprocessors are, how the microprocessor are made, how is the simple circuit of the microprocessor are made, they uses their application. Basically they are called as an integrated circuit. Integrated, as the name suggests, that all the components are connected together in a single chip, and then according to the particular variation we calculate it. Let's take a small example here, that I want to make a IC here which has 4 NAND gates. I can make it very easily, 4 NAND gates. The first NAND gate is here. So if we look like this, this is 1, 2, 3, and the second NAND gate is here. It is 4, 5 and 6. So this is the supply, let it be VCC, And in the same way, we'll make in the upper way that this is will be 8, 9, 10, and then again we can see that there is output 11, 12, 13 and 14 will be again minus VCC. So, what we are observing here is that we are making a NAND gate, and from the NAND gate we are making the integrated circuit. NAND gate is basically there is nothing, we are using the diodes to form it, and then we are using the transistor to make a NOT gate. So, the NAND gate is basically formed here, where 4 NAND gates we are using, and then from the 4 NAND gates we are using the integrated circuit. So, this is how the microprocessors are generally formed. Here we can see here that microprocessor as a brain of the computer system, yes, because microprocessor, depending upon the nature of the microprocessor, depending upon the nature of the IC that we are using, that is basically that defines the system configuration, that defines the the performance of the particular system. Then we have, this was the example shown to you. Then we have the introduction, the microprocessor controlling unit CPU, which is capable of the fabricating a very small chip for performing all the arithmetic logic unit operation and the communication with the external devices connected to it. Basically, the performance of a computer, the performance of a system depends upon the processor used. So, processor is very much capable to align with the ALU and to do all the particular operations of the particular computer. So, the microprocessor is a set of instructions. Microprocessor is the basic, the mother of all the particular circuit, which has the memory allocation also, which give instruction to all part of the computer to perform the work. So, microprocessor has a small examples here again, input unit, microprocessor and output, and this is the memory. So, what the input that we give it to the particular computer, then that particular computer follow that particular input, and then we come to the particular output. So, we say that from the microprocessor we give the input and the microprocessor processes that particular input to get the desired output. Then we have some definition. The digital computer consists of a CPU called microprocessor, desktop computer, and then the term is generally with the personal computer is generally used. Microprocessor, first we have instruction set, then we have bandwidth, then the capability. Instruction set with a particular set of all the instructions that we give, then the instruction will follow. Then bandwidth is basically the nature and the speed of this, which decide the number of the information generally used. As we have discussed that the entire time is break into the small time pulses. In that case, we have a clock speed, and depends upon the clock rate and depends upon the configuration, the clock will generally move. We have a cost, size. The most important feature of the microprocessor is a low cost. So, we can design it at a low cost. Okay, then we have a accessibility is very high, and then we have the power consumption. The power consumption again depends upon our users, that how we are using the power consumption. Then versatility and the reliability. So, these are things that is required to calculate this. So, what we do in this is that we will discuss the microprocessor basics, that how the microprocessor is designed, how the memory allocation will design. So, in the coming videos we will discuss more about the microprocessor and its application. So, in this video I have tried to enlist the basics of the microprocessor and the shift registers. Hope all students have enjoyed the video and learned about the shift counters and then the microprocessors. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.